Okay, so next talk is called You Ain't Gonna Need My Dry Kiss. Or will you? So a little bit of the terminology. Maybe not everyone is familiar with these kind of programmer terms. So KISS, what this means is keep it simple, stupid. And actually it comes out of the American military, this term. It comes out of the Navy. They even had a project KISS apparently in 1960. And somehow through some channels, this got, adopted by programmers. So just, the idea of simplicity. Then dry, do not repeat yourself. That was coined by in a book from David Thomas and Andrew Hunt called the Pragmatic Programmer. Kind of a tongue twister there. And so you can look at the date, and this already tells you something a little bit. 1999. What comes to mind there? OOP, Java. This was really at its peak, I would say, in terms of popularity back then. So yeah, keep everything, nice and clean, no repetitions in code. Then Yagni, you aren't going to need it. That was coined by kind of the extreme programming movement, which it was one of their basic principles to say, well, okay, just forget all of that. Let's just solve the problem as directly as possible. This was I would say, a precursor of the agile movement. You can maybe even see that it grew out of there, kind of. So, I would say the classic thing that everyone learns in school is dry, right? Like, do not repeat yourself. Your code should be organized in such a way that nothing ever gets copied and so on. So be careful with that, right? And saying here the problem with that. Well, let me give you a little bit of a flavor here. So let's say you're looking at a piece of code and you notice like, oh no, we're repeating the same code twice. Okay, cool. We just create helper functions, maybe in its own helper class, in its own helper module. We call that and fine, right? We have now not repeated the same code. But oh, wait, the same parameter has already been passed twice in the same way into the same function. So actually it's still repeating itself. So, okay, maybe we create a class factory to deal with that problem. So then we can, have this very smart factory instance that we then can call over and over again that has already these parameters stored, and then we have successfully dry-fied. But wait, we already called this factory twice in two different places. Oh no, yeah, okay, let's invert control and create dependency injection machinery around it and so on and so on. And so, it quickly becomes a bit excessive, the amount of abstractions. If we say, well, even just once we repeat, we need to create abstractions to avoid it, right? And my slides just crashed. How did this happen? Well, I guess I have to scroll now through 3 pages of stack trace. Or we can just, start over and start with Kiss and Yagni. Keep it simple, stupid. You ain't gonna need it in practice. And its pitfalls. Wait, no, don't worry about that subtitle. It's all gonna be fine. Okay, so where do we start? So this takeaway from extreme programming is that we start simple and we build up iteratively. So let's do that. Let's start with, Yagni, basically. So when we start solving a problem, we have all these questions coming up, do I need cloud logging? Do I need to have an event streaming system? Oh, let's throw Kafka at it. Do I need a DB even? Do I need it to be auditable for 10 years and so on and so on? You just say no. No one told us this yet, so let's just assume we don't have to, right? you ain't gonna need it. And you just solve the problem you have in a very minimal way. I say here minimal deployable state. Wait, okay, deployable in our organization means, okay, I need to actually maybe Dockerize it. Okay, so these things then start to come in, right? Once you start to need them. But once we say, okay, we need something, actually, we need, for example, to Dockerize it, we go right to KISS and say, well, but how do I, like, what do I do now? Do I do Docker or Docker Compose or Swarm or Kubernetes? You just say, okay, what is the least complex solution? Let's just stick with that for now. Okay. So if the idea is Docker, let's say, then we just stick maybe with a Docker file. Only when we see that, for example, we have a lot of parameters passing into the Docker command, then we start maybe adding Docker Compose to it, or when we have multiple containers to orchestrate and so on. Compose is like the next less complex option. This can be, you know, this exercise can be done for all aspects of code. For example, you can start with just copying code, or you can go to functions, then again classes with methods, inheritance, object factories, and finally I would say dependency injection is kind of at the top of the you know, abstraction hierarchy there. So we see that, you know, Yagni and Kiss, they kind of they you know, they get along really well. They kind of love each other, right? One goes to the next basically. And the question is, what about this dry guy here, like poor guy standing in a corner? Well, let me illustrate this with a little bit of practical example that we actually got from Poseidon work. I think Dorota and also Peter mostly are very familiar with that one. So the goal here is to show you that things may start out simple, but it quickly gets out of hand. And so let's see the story, right? So we start with this kind of computational code here that is supposed to just give us maximum drawdown and then high and low price and the high and low price date. And we just calculate this based on, you know, the max drawdown is based on returns, and we put it at the end into a data frame and return it. Now, Julian, for example, comes to us and says, hey, but you know, we need these different lookback versions for our key figures. So please, can you give us like 3 years and 5 years and since inception and all these, you know, versions of the key figures basically to deal with that? Okay, we say, oh, fine, you know, we have these different lookback options. We create a loop around it, you know, a little bit of scaffolding. We put the loopback name at the end where we assign the results, and we just keep assigning results until we are done, basically. So far, so good. But now Julian comes back and said, well, wait, so max drawdown should actually use end of month data, while everything else uses daily data. Okay, like we didn't know about that requirement first, but okay, let's do that then. We create, you know, 2 different price sources, or we take in 2 different price sources already from database. Basically, one is daily, one is monthly. We compute the look back up here, right? We compute the returns. The returns so far we only need for maximum drawdown, so we can only do it with the monthly version, and you know, we use the daily version for the rest of our program, and then we are fine again, right? Oh, but please add volatility also, like 3 months later, right? Well, volatility doesn't sound too difficult. Like we already have returns, so from returns we can quickly calculate the volatility also. So all we have to do is add like these 2 lines there for the calculation and add it to the result. Look, it was easy, no problem, right? Oh, there's a bug in here. We never asked whether volatility actually needs monthly or daily data. we didn't even think about it because the returns that we calculated here, and this might even be on a different code page, you know, it actually uses monthly as an input. And but we omitted it because we only needed it in one place in the name, and so kind of forgot about it and said, well, no one is ever going to use returns for something else, right? I mean, keep it simple, stupid, okay? Well, we probably just created a bug here. So the point here is that saying completely omitting the try principle is kind of inviting, you know, it really is cool. Like you're very fast at solving tickets and creating features, but it's kind of dangerous. Like you're inviting a lot of maintainability issues later on. And I would say that if you take it at face value, these two things like Yagni Kiss and dry, they're almost like in opposition of each other, right? Like dry kind of invites these abstractions and complexity, while Yagni and Kiss invites being fast and just solving your problems, right? So kind of you got to ask the big question here, right? How did dry get violated in the code? I mean, well, if you look at the code again, like, does anyone in the audience maybe has an idea? Like, what about this is not dry? You know, where is this actually violated? No? Remote audience, maybe? Sorry, what?
Themselves in terms of daily monthly. I guess the same actions.
Very good, very good. Yes. So we have this data granularity thing that is colored in red, which is you know, how granular is the source data? Is it daily or is it month, end of month data? And then also the look back in green. It's kind of, these two concerns are repeated all over the place in the code, right? It's throughout the code here. And so the question is, well, I mean, does this explain it? I would say it explains it, because what we actually, the reason we had this bug was that we forgot to name returns funds to returns fund monthly. And then we just took it for something that was not meant to use monthly, right? I mean, yeah, I should have a word with the editor of these slides. It's just not serious enough, I think, for our matters here. But yeah, let's try to dryify our problem. Okay, so the idea with factoring this out, these concerns of look back and granularity, is that we use classes here because classes, this gives us the ability to just instantiate them with the version of the concern I have, and then I just keep using that class in a way, right? And we use data classes here because this also kind of follows the dry principle. Well, with data classes, we can avoid writing our own initializer functions, like the init functions, you know, that's just generated for us. All we have to do is defining these class variables, basically. Well, it interprets them as either instance or class variables based on the type info that we add. But the base thing here is that we just avoid init functions, and that's also one possible bug that we avoid. So it's more dry in this way. Okay, so that's the first thing. Then we are able to initialize a certain instance of our calculator class with a lookback, so that this concern is now kind of isolated on this class level. And now we could, of course, have all these different functions defined there, but the idea is here to use a base class, so it would raise a not implemented error on the start date. But we just use a base class with some basic scaffolding, and then we have basically the daily subclass and the monthly granularity subclass. because they will have different code in which the start date for the look back is going to be calculated, right? That's how we specialize for the different granularity. And also we can specialize by having the different calculator methods, you know, defined on the subclass where it's actually meant for. So in this example here, I'm assuming that you always, for example, want maximum drawdown with monthly, and you want volatility with the daily source data, just for this example. Okay, so then you would define them on the subclass, and you know the other class doesn't even have that calculation, so you could not mess it up basically as long as you instantiate the right class. And instead of just repeatedly calling those calculator functions, what we do is we have this little registry here. It's just a dictionary called result fields by func, which gives you both how the result fields are called and what function is used to calculate that result field. And then we can basically just call calculate all on our calculator class, and it will prepare inputs. So for example, it will do the look back in here, create this kind of input dictionary that is passed into these calculator function. Here we can then just take, you know, the input we need. Basically, we just take returns for volatility, we take prices for this one. So this framework will then automatically pass in the right inputs to our function as long as they are named as they are in the input dictionary. And that way, when we now look at the user code, it got quite a bit simplified. And if we look at, well, where are our concerns repeated, we have the look back in the loop, and then just in two places where we store, you know, with the appropriate name. We have the granularity each time in the class name, and then in like what input do we take for it. And this now looks reasonably dry. No, we have not many repetitions of these concerns anymore. By the way, this style of solving it is quite inspired by a talk by Gary Bernhardt called Boundaries, where he calls it faux O. So it's kind of, he combines OOP with functional style programming, because while we do OOP in terms of classes, we never actually change the state of the class instance after it's been created. So one thing I omitted was when you go back to these class definitions, I would actually always use data class with frozen true, because that would automatically check for you that you hold this contract. Like once an instance is created, it's never changed anymore. And so we only pass in the thing at the initializer time that don't change, basically. And then we just use it in a functional way. We pass in the input, we get an output, it's pure functions, and that way it also is nicely testable. Because if you just have pure functions with no side effects, all you need to do is create, you know, a mock instance of that function. It doesn't need anything else, basically, besides a look back. You pass in some mock data, you check the result, you're done. It doesn't do anything like, you know, database retrieval or anything like that. So it's nicely encapsulated. So to finish this up, how do we marry now these principles, Yagni, Kiss, and Try, like when we look back at this example, right? And I would propose here to use a rule that also comes out of a book from Martin Fowler in 1999. He introduced this rule of free. So we only ever start refactoring after free instances of something, basically, right? So you start basically with Yagni, which is maximum dry, right? No code is the driest code you can have. Once you need something, you do it. Then there is a first repetition where you're saying, wait, we don't refactor yet because we don't know enough of the problem, like the different patterns that can emerge. Or maybe it's just an outlier. Maybe it's just one repetition and we don't worry about it. Then when the second repetition comes, that's when you say, okay, now I have repeated it 3 times basically, and you start refactoring and create a dry version. And this is how I would say at BIE, for example, at code reviews, if you know, I see that there's a third repetition, then we go into this refactoring. It might even be in a follow-up ticket if we think it's still fine, but it's on the board. We need to do something at this point, right? And we try to follow this principle relatively closely. And I would say it's reasonably maintainable thanks to that still. But you know, maybe Peter and Dorota and Attila are better judges for this. So the way to kind of marry these 3 principles is with this rule of 3, and with this, you know, the 3 formed a love triangle and lived happily ever after. Okay, so here's a couple of references also, and that's it. That's all I got.